Alright, so this is the introduction to vectors. I just give a little up here for the definitions of what we're going to actually use, how we're going to use it. So basically if we have an A, B here, point A and then B with a vector along the line up top, basically what we're going to do is it's going to ask us for, take x2 minus x1 and then y2 minus y1, right? Just take the second one, subtract from the first for all of our components, x and y, right? If we have the lines around them, well, that's asking for the length, right? Which is just the distance. And the way we want to imagine the distance is, well, we can think about point A being here, point B being here. We can draw a line between them. And if we were to connect those points along the x-axis and the y-axis, well, what we end up with is a triangle. So the way we can imagine doing or calculating the distance between them, or the length, is imagining that the difference between x2 and x1, that's going to be the base. y2 minus y1, that's going to be the height. And if we use a squared plus b squared equals c squared, well, what we end up with is d squared for our distance is equal to x2 minus x1 squared plus y2 minus y1 squared. So we can square root that to find the distance absolutely, right? That's basically what we're going to do for this entire question here, right? So if we look over at PQ, well, what do we have? We want Q first, so we have -1. Then for our P, what's our X? Well, that's 1, so we subtract 1. Q is going to just be, for y, it's going to be 1. Then what's y2 for p? Well, that's 2. So then we end up with this result over here. Okay, and we're just going to repeat this process over and over again, right? What do we have here? We have r. This is going to be our x2. So let's find that. Yeah, x2 here. Then we're going to have our p. So we're going to look for p. That's 1. Then what's the next one here? r, -1. Then what's this? For p, 2, so it's going to go to -2, right? Because we're always going to subtract. We're going to just basically follow this thing over and over again. If we repeat this process 100 times, it's a very mundane. But yeah, we end up with this result over here, right? I just like to look at the problem, look at all the pieces that we're going to need, and then sub those back in, right? So this is just me going, oh, we have PQ, PR, PR, RS, QS, PS, and then QR. So I'm going to calculate that all, and then I'm just going to plug them all in, right? So then I went over to 1. It's like, what do we need? PQ and PR. Well, I calculated it here, right? PQ, PR. It's asking us to add them. So take this result. Just take this result, add it to this result, and we end up with this, right? So that again. If we have a 2 in front, though, a coefficient, we're going to want to distribute that in first before we do anything, right? It's going to go like this. It's going to go to every single piece within our component. You're not just multiplying into the first. It's going to go into the 1 and the -3, right? So we do that, then we just add them together. We get this. What's the next one? 3. The length of PQ. So we've calculated PQ, right? That's just x2, x1, y2, y1. We get this vector over here. So now we're going to do the distance. Well, the distance is just going to be x2 minus x1 squared, right? We've added those together, so this is going to be x2 minus x1. And then y2 minus y1 squared. Well, this is going to be our y2 minus y1 squared. Put that into our square root, right? Because that's the distance, the base, and the height. Squared all of our components. And then we get this result here, right? Once again, I would not put the 2 in here first, right? You can just calculate it as is. Right. So then we're going to want to take that, calculate it. Well, we just have the length of 1, 0. Well, that's just going to be 1 squared plus 0 squared, which is 1. Which is 2 times 1, which is 2. Yeah. And then minus the length of -1, -1. Right, we're always going to square them, so they're going to end up positive. Make sure that you put brackets around it. Right? It is not -1 squared, it is bracket -1 and bracket squared. Like, those are very different. That's still -1, that's 1. Right? So just make sure you put brackets. I've seen that mistake too many times, and it's quite costly. The next one. Okay, so if we have the coefficient inside, well, we can distribute it first. Right, and then just add them together. That's going to make things much easier. Get this. Go through the square process again. 5 squared plus -8 squared. Remember, square brackets. Or curly brackets, whichever one you like. And then we get this result, right? What is 2? Let v equal this, w equal that, u equal that, x equal that. That's a lot of stuff. Answer the following questions about the list of vectors. Give reasonings for your answers. Okay. Right. So the first one is, this is what this symbol means. This means, is it orthogonal? Right? So what does orthogonal mean? Basically, if we take the dot product of some vector v with w, if it's equal to 0, we're going to say it's orthogonal. If it does not equal 0, we're going to say it's not orthogonal. Right? So we're just going to use that little piece there to work through the problem. So is v orthogonal with w? Well, we're going to look at the definition. We have the dot product. Right? What is the dot product? So we can imagine we have pieces a, b, c, dot, d, e, f. So the dot product is basically, we're going to take the first element, we're going to multiply by the second one. Right? The first of the first, then the first of the second, then we're going to multiply it over here, and then we're going to multiply it over here. Right? So the second goes to the second of this, third goes to the third of this, first goes to the first of this, multiplying them across, and basically what we're doing each time is we're adding them. Right? So this would just be equal to AD, right? First, plus BE, second, plus CF, and that's it. You just carry that process over and over again for however long the vector is. So we have v dot w, well, 0 and 1, negative 1 and 1, and 1 and 1. So using this piece over here for how it ends up, we see that we have 0 times 1 plus negative 1 times 1 plus 1 times 1. And this is just negative 1 plus 1, which is equal to 0. Using our little definition up here, right, we see v dot w, if it's equal to 0, that's orthogonal. So since this is equal to 0, this is orthogonal. Right. Next one is, are v and u parallel or antiparallel? So in this case, we can just look at it. What is v made up of? Well, v is equal to negative 1 u. So that means antiparallel, right? So we have a negative magnitude, which you can just imagine as like a coefficient. Right? Negative magnitude, that's going to be anti-parallel. So similarly, the opposite of that is just positive of this. It's going to mean that it's parallel. Right? And, well, that's actually the next question. What can you say about the vectors w and x? Well, we see that if we multiply w by a half, we get x. So that means since it's positive, right, positive coefficient, positive magnitude of that vector, it's going to be considered parallel, right? We're not going to look at 0. We do not want that, right? Is it positive or negative? Negative, antiparallel, positive, parallel. Okay, the next one is v plus w orthogonal to u? So we're going to want to look at this first, this piece first, right? V plus w. We can split this up. So let's calculate v plus w before we do the dot product. Take our vector v, take our vector w, add them together. We get this, right? So after we get that, we're going to put that back in, v plus w dot u. Well, we take this result, put it back here. Do the dot product. We see that's 1 times 0, that's just 0. 0 times 1, that's 0. And 2 times negative 1, well, that's negative 2. Which is not equal to 0. So therefore, from our piece up here, we say that it's not orthogonal. Right? 5. Show that there is a real number alpha such that alpha v plus w is orthogonal to u. Yeah, so the way we can start this is just start with the piece on the left, alpha v plus w. Well, alpha v plus w is just going to be equal to alpha over v vector plus w. We can distribute that alpha into our v to get this piece here. Then we add them together, and we get this piece here. So this is our alpha v plus w. Now we're going to go back. We're going to do alpha v plus w dot and dot u. Well, that's equal to this, dot, 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 dot. Take the dot product of the two. We're going to end up with this, right? 1 times 0, that's 0. Negative alpha plus 1 times 1. Negative alpha plus 1 is just itself. And then alpha plus 1 times negative 1, that's just negative alpha minus 1. So the positive 1 and the negative 1 are going to cancel. We're going to get negative alpha, that's negative 2 alpha. Now what we're going to do is we want to find a real number alpha such that it's orthogonal, right? Such that alpha v plus w is orthogonal to u. So if we want to find that that is the case, we're going to set this equal to 0, right? Because we want the dot product to be equal to 0. So we end up with negative 2 alpha, that's all we have left, is equal to 0, which implies that we have alpha is equal to 0, which is a real number, right? So I would just put that here as a real number. Boom. So we can check it. So if we put our alpha equal to 0 back in, we're going to get alpha v is just going to go to 0, right? 0 times v is just 0. So what we're left with is, what is this? W dot u, right? If we check w dot u, 1 times 0, 0, 1 times 1, 1 times negative 1, that's 1 minus 1, goes to 0, so it works, right? So that is correct. The next one is v plus u orthogonal to u. So we're going to do the thing again, v plus u. What is that? Well, 0, negative 1, 1, plus 0, 1, negative 1, dot u1, negative 1. Well, if we add these two together, we actually notice up here that, well, v is just the negative 1 of u. It's just exactly negative 1, so if we add them together, well, they're going to cancel out, right? So that's going to go to 0. Well, then we have 0 dot some vector, and that's just going to go to 0 as well, right? So that's orthogonal. Yes, determine whether the given vectors are parallel, antiparallel, or neither by using the cross product. So I'm just going to write the neither out. Neither is such that we have v dot w, right, is not equal to 0. Right, so that's the little case there. But yeah, so we want to use the cross product for both. It's not completely necessary to figure it out, but you know, there are more complex cases where you're not going to be able to immediately spot that, oh, maybe it's just negative 1 of another vector. Right, it might be some crazy number like, oh, it's anti-parallel because it's negative square root 2 over e or pi or something. Like, you're never going to be able to figure that out. All right, but what is it? 1. Okay, yeah. So if we do the the cross product of v times w, well, the first thing we can do is we can actually just simplify w. Right, this is 2 pieces here. We can just turn that into 1. And I did that here, right? 3 minus 3, that's 0. 2 minus 4, that's negative 2. 1 minus 7, that's negative 6. So I just simplified it out. Now what we can do to make this much easier to look at is we can write them out in columns by x, y, z, right? So we're going to take our x coefficient, y, z, store them under here. I did this with v and then w next. So that's v, that's w. If we start taking the cross product, we're going to want to use, well, as it says, a cross, right? It's going to be a crisscross. Going to go down right and then down left, right? This is also known as the determinant in another context. Very, very similar. Yeah, so what we're going to do is we're going to store x, y, z. After we do that, we're going to start from this place over here, this y here. We're going to go down right. We're going to multiply them. Then what we're going to do for the next step is we're going to move over 1 right. Move over 1 to z, take the first value underneath of it, which is 3, then multiply that by negative 2. And what we're going to do, if we start over y, we go down right, that's positive. If we go down left, that's negative, right? So positive, negative, positive, negative. Then for the next step, we're going to go to 3. We're going to go multiply down right, right? Well, what's down right of 3? I know it's not on the place, but it's just underneath of x, right? So you can imagine this just infinitely repeats over and over again. x, y, z, x, y, z, x, y, z. So to the right of 3 is x. Down right is 0. So we have 3 times 0 minus, then we're going to start at x, 0 times down left, negative 6, right? Down right, down left, down right, down left, down right, down left. Positive, negative, positive, negative, positive, negative, infinite crisscross. Okay, so for our last piece, we've done our y, we've done our z. The next piece is x. We're going to start here. Well, we have 0 times negative 2 minus, now we're going to go to y, 1 times 0. And once we check that out, we see that we end up with 0, 0, 0. So in this case, since it is equal to 0, well, it's parallel or antiparallel. It doesn't tell us which one it is. Maybe we're going to need to figure that out. But it tells us that it is not neither, right? If it were neither, it would not be equal to 0. So this one we actually can see very clear. Right, if we simplify. If you didn't simplify, this is going to be very hard. Always simplify if you can. But we just see that w is equal to negative 2v, right? Multiply v by negative 2, we get 0, negative 2, negative 6. We see that w is equal to negative 2, negative 6, so that works, right? And since we have a negative coefficient or negative magnitude, this implies that this is anti-parallel. All right, what's 2? So once again, we're going to have v cross product w. It's already simplified here, which is very nice. Right, store our things, x, y, z. Well, we have 1 here, 0 here, negative 1, 1, 1, and then negative 2. Right, start from our y. Right. Then we have negative 1 multiply down right, negative 1, negative 2, minus z, 1, 1. Then we're going to start from our z, 1 times 0. Then we're going to start from x, 1 times negative 2. Then finally, start over x, 1 times 1, go over 1, go right again, because we're going to go down left, negative 1 times 0. Right. If we simplify this, we see that we get 1, 2, 1. Well, that's not equal to 0. So we say, therefore, it's not parallel or anti-parallel. It's neither. Right. It is neither. Okay, so find the distance from the point P3, negative 2 to the following lines. So if we have these following lines, well, with variables already, well, we see that this is just x, y, right? So if these lines are equations, will equal to 0, well, we can just put those points in, right? So we say the distance is just going to be equal to the equation over the square root of the length, basically, right, of each of our components, right? So that means if we have, say, we had like ax plus by, well, what's that going to be? Well, it's just going to be a squared plus b squared, right? And then over ax plus by, right? That's going to be it for that. So using this little piece here, we're just going to put our points in. Well, 3x minus 2y minus 6, everything's equal to 0. That's good. Over the square root of, what do we have here? Well, we have 3x minus 2y, no variables after that. So we're going to take 3 squared and then plus negative 2 squared. Remember, keep those brackets, very important. It's not negative 2 squared. It's negative, like that. So we put our points in. So just simplify that, and then we get the result, right? Same thing for the second question. Except for this question, we have to move it over first, right? We cannot just leave it like that. So we have equals 13. That's just going to be 7x minus 2y minus 13 equals 0. Right. So always do this. Please move it over. We want that to be the result. Okay. After we do that, we get this piece. Yeah. And then we just put the points in again, right? So this is just simplification. Add them all together. Collect like terms. Blah 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 blah. Then we get this result. If you can simplify the square root and the top, you know, the denominator, I would do that. Numerator. All right, 5 is basically just a more complex version of number 4. It follows the exact same thing, right? So we have ax plus by plus cz. Right, well, what are we going to end up with on the bottom? Well, we take our a squared plus our b squared plus our c squared. That's our bottom. Let's say we have like plus d. Well, then we just get ax plus by plus cz plus d. And then we have some point, right? Point 1 or point, let's say like e, f, g. Yeah, then we're going to put those points in. So we have that here. Everything's on the left side. Good. It's all equal to 0. So we may begin. We put our points in. This is just going to be our x. This is going to be our y. This is going to be our z. Just going to put them in our respective spot. We have x is equal to 1. So we have 2 times 1. Y is 2. Negative 3 times 2. Z is just negative 3, so negative 6 times negative 3 plus 14, our constant, over our coefficient for x, coefficient for y, coefficient for z, all those squared, just added together, right? End up with this piece, simplify, and we finally get the solution.